Welcome to day 2. We're going to be doing bearings and word problems today. So start off just with this first page going over a different type of angle definition. And it's called bearings. So when a single angle measurement is given, such as 164 degrees, we pretty much understand that to mean that it's coming from north, which is straight up, and then going clockwise. Okay? So here are just a couple different examples of them. So we go from north, 32 degrees, clockwise. Here we're going from north, 164, from north, 304. So what's really useful to remember here is just kind of if I break this up, so here's 90, 180, 270, and then all the way back up to north would be 360. So you can use those as estimates of kind of where it's going to be. So for this last one, since 304 is bigger than 270, I know that I need to go all the way around. Okay, so I need to go through here, so this is 270, and then a little bit past that. So it's just an estimate of where it is, but you should always have it at least in the right quadrant. There's a variation off of this type of bearings, can't talk. And it's very similar. It just kind of sets up using a little fancier notation. So if we look at this first one, okay, it says south 31 east. So that means that we start at the south measurement and we go 31 degrees towards the east. So we're starting south going towards the east. Okay, and remember that we have north, east, south, and then west. Slight variation on this, so you start from south again, but now we're going 40 degrees towards the west. So instead of going, towards the east, I just go towards the west 40 degrees. Okay, and since I know between south and west is 90, I could actually say that this part right here, okay, that needs to be 50 degrees because then the 50 and the 40 will add up to 90. So we can kind of use this to estimate what some other angles are. Same idea here. I have north 42 east. This time I start from north and I'm going 42 degrees towards the east. And again, north 52 west, so I start north and I go to the west. So when we're doing this type of fancy bearing, we always start with either the north or the south, and then we go towards either the east or west, whatever number of degrees it tells us. All right, so we'll do these 3 quick examples, just so you get the hang of it. So we have 235, so it's more than 180, so I'm going to start from north and kind of come all the way around. Here's 180, and it's less than 270, so I'm somewhere in this quadrant. I don't exactly know where, but I'll stop right here. Here's where this angle is measured, roughly. Okay. Here we have the fancier notation. So it says start from south, so I'm going to start on this line. Start from south and go 20 degrees towards the east. Okay. So starting from south, 20 degrees towards the east. So this little part right here is 20. Okay. And then again, because south and east are 90 degrees away from each other, I could label this part right here as 70 as well. Okay, and that's just because they're 90 degrees. 70 plus 20 is 90. Here we have a negative angle. And set up like the normal bearings. I'm going to go from north, but I'm going to go backwards. Okay, this time I'm going to go counterclockwise. So I go 60 degrees this way instead. Okay, same with before. 60 and some angle right here need to add up to 90, so I could label this part right here as 30 degrees too. Pretty straightforward, right? What we'll do now is 3 different examples that use this. 2 of them really use it directly, and 1 of them it's just kind of just a practice question. So at this point you can stop watching, or you can continue on with the practice. Okay, Coast Guard cutter travels at 30 knots from its home port of Corpus Christi on a course of 95 degrees for 2 hours. So that's a bearings course from north, 95. It's then going to change its course to 185 for another 2 hours. We want to find the distance from where it started to where it is right now. Okay? So I'm going to start off just by kind of putting a little north, south, east, west line there. And that's when I'm going to start my first drawing. So first thing I have is this 95 degrees. Okay, so I'm going to do 95 degrees from north. Okay, and then this is how far I'm going for about 2 hours. So I'm doing this 2 hours at 30 knots, so this is really a distance of 60, and I never remember what units knots is measured in, so we'll just leave it at 60 for now. Okay, when we reach this point, 2 hours later we reach this point, we're going to change directions. So what I'm going to do is put another little north, south, east, west right there. Okay, come back. Alright, now I'm going to go 185. So here's 90, 180, and just a little bit past it. Okay, and again, I'm going for another 2 hours, and since I'm still going at 30 knots, I'm still going for 60. Okay, and now this is my ending point. So this is where the boat is right now. And one of the things that we're going to practice with here is that we don't want to assume that this ending point and this starting point are directly north-south of each other. Okay, so I purposely didn't draw it that way. In this case, I'm pretty sure they actually are, but in most cases they're not. So you don't want to draw it that way. You want to kind of not do that, because you'll basically just be working with the problem and then just assume that they are north-south, and that can create a lot of issues for you. Okay, so we don't actually know whether those are north-south from each other, so I purposely drew it so that they don't look that way. And our ultimate goal here is that we're trying to figure out what is this distance right here. Okay, find the distance and the bearing. Ooh, that's going to be a little trickier. Of the Corpus Christi port to the boat. Okay. So one of the things we want to do at this point is start labeling as many of the angles as we can. So this original angle, the 95 that we did, okay, so it was 90 for us to go from northeast, and we went 5 degrees past that. So that little part right there is 5 degrees. And since all east-south, all east-west and north-south lines are parallel, by alternate interior angles, I know this part right here also has to be 5, okay, because it's alternate interior to that little angle way up there. When I use the 185, okay, so when I started here, I went 90, 180, and then I went 5 past it, so this little part right here is 5. And I know that if I were to go from south all the way up to west, that's 90 degrees. Since I've already gone 5 of those degrees, that means that there's 85 degrees left in here. So this little angle in here has a 5 and an 85, so this is actually, despite the fact that it's not drawn that way, it's a right angle. So that's kind of cool. Alright, so since this is a right angle, this means it's a right triangle. And if it's a right triangle and I'm trying to find side length D, which is opposite that right angle, I can just use Pythagorean Theorem. So I have 60 squared plus 60 squared has to equal D squared. Okay? If I wanted to be even more fancier about this, I could recognize this as a 45, 45, 90. Okay? If these two side lengths are equal to each other, then this has to be an isosceles triangle. And if it's an isosceles triangle, the base angles, okay, so these angles, have to be 45. Okay, because they have to be equal to each other, and since the other one's 90, they have to add up to 90. So this is actually a 45, 45, 90, and I can just use the shortcut. So D is actually just going to equal 60 root 2, whatever units we're in here. And there's the distance. Okay? Alright, so to find the bearing now, which is the next part of this question, it's a little trickier. But we actually just did a lot of the hard work by figuring out that this is 45 right here. And you can see now that it definitely can't be north-south. Okay, if I kind of zoom in just on this one little angle right here, okay, I have 5 degrees going this way, and then another 45 is where it's going to be. So here's 5, and then the inside angle here is 45 degrees. Okay, so that's a zoom in of this top angle. And if I'm trying to find the bearing from Corpus Christi to the boat, so I'm going from up here and I'm looking down this way. So I want to actually know what this bearing is right here. And we already know most of it. Okay, so from north to east is 90 degrees. It's a really fat marker. Okay, so 90 degrees, and then we have 5 degrees, and then we have 45 degrees. So just have to add those up. Okay, so that's 90 plus 50, so that's 140 degrees. So the bearing from Corpus Christi to the boat is going to be 140 degrees. Okay? And I recommend that you do this kind of zoom in sometimes. If you're trying to answer one of these questions and your writing's really messy or there's too much going on in there, then you just kind of pull one of the angles out, make it really big so you can actually see what's going on. Okay? We have to be really careful that we read this question right and that said we're going from Corpus Christi, because it would be a different bearing if we were looking at it from the boat and going back towards Corpus Christi. Can't talk. Christi. I'll leave that one in there for you, okay? Moving on. So this one has less to do with bearings. This is just a normal type of word problem that we have. It's slightly different from the ones that we worked with yesterday or the day before, or whenever you're watching this, who knows. So here we have, from the top of a 100-foot building, a man observes a car moving towards him. So we'll draw our fun little building again. Okay, there's a car coming. Here's a nice door and some windows, you know, the usual. So someone's looking at this from the roof line. So what I'm going to do is kind of extend the roof line like this. This gives me some sort of reference area to start from. So it says that the angle of depression of the car changes from 15 degrees to 33 degrees. So there's a car driving, it drives a certain amount of distance. Okay, and the angle of depression, so depression means that you're feeling a little down, so we're going from that dotted line down, so here's 15 degrees, or from this dotted line down all the way is 33 degrees. Do you remember in the last video I said that angle of depression and angle of elevation are actually the same thing? That's because of alternate interior. This dotted line up here and the blue solid line on the bottom, those are parallel lines. So by alternate interior, this 15 translates down to here. This is also 15. The 33 is alternate interiors to here. So this is 33, and we know this is a 100-foot building. Okay? And our goal is to find this distance right here, how far the car has traveled. So for now, the easiest way for us to solve this is to actually label this part right here as y, and I'm going to have that go from the building to where the car currently is. And x is just going to be from the distance that it traveled. Let's see. So if I look at this first little triangle here, I'm going to highlight it for you. There's a triangle right here. It's a right triangle because we're going to assume the building has to be square with the road. I have an angle of 33, an opposite side of 100, and an adjacent side of y. So I can write a tangent equation right here. So I can say that tangent of 33 degrees has to equal 100 over y. I can do something very similar with this kind of larger triangle that uses 15. Okay, so if I'm using 15, 100 is still the opposite side, but now this adjacent side is actually y plus x. Okay, so when I write this one, it's going to be tangent of 15 degrees equals 100 over x plus y. So I'm ultimately trying to solve for y, or sorry, solve for what x is. So I'm going to take this equation real quick and solve it for y. So I'm going to multiply the y to the other side and then divide the tan 33 away. So now I have y by itself. I'm going to do something very similar on this side. I'm going to get the x plus y by itself, so I multiply it over and then divide by the tan 15. And to get x by itself, I'll just take this y and I'll subtract it to the other side. But remember that y is really this. So I can write this as 100 tan 15 minus 100 over tan 33. And this is the exact answer. And if I type this into my calculator, I get that the car has traveled approximately 219 feet. Okay, so this is just less bearing practice and more just a word problem you might encounter practice. So here we have some boat traveling 40 knots. Again, who knows what units that's measured in. From Fort Lauderdale on a course of 65 degrees for 2 hours, then changes course to 155 degrees, and then it goes that distance for 4 hours. We're going to determine the distance and bearing from Fort Lauderdale to the boat. Again? So when I start off with these, if you're not really sure where things are going to be, you always kind of start in the middle of your page. So I kind of started in midway between the end of the word problem and the bottom of the page. And I drew my little north, south, east, west. I'm going to follow the first bit of directions. It says travel at a course of 65 degrees. So that's coming from north, 65 degrees. I'm going to do that for about 2 hours. So here's 65 degrees. That means that this little tiny part right here between where my boat is traveling and the east line, that has to be 25. 65 and 25 is 90. Okay, so if I'm traveling 40 knots, 2 hours, this is going to be some sort of measurement of 80. Okay, and I get to this point right here and we stop and we're going to change directions. Okay, so I put another little north, south, east, west line. I'm changing directions now to a bearing of 155. Okay, so I go 90 and then past that, but not all the way past 180. Okay, and I'm going for 4 hours. So the line I'm drawing should be roughly twice as big as the one I've already drawn because that was for only 2 hours. Okay, so 4 hours at 40 knots, this is going to be 160 units. Here's where I stop. Okay, if you want to, you can draw another little north, south, east, west line there, and then we can connect it back to Fort Lauderdale. Okay, so here's Fort Lauderdale, and here's where the boat currently is. So we have some things that we need to figure out. Okay, I'm going to put those in red right now. We need to know the distance that the boat is. That's going to be the easiest thing for us to figure out. And then we need to know the bearing. Okay, so the bearing is going to be this part right there. And if I kind of zoom in on that, okay, so here I have 65. That's a terrible 65. Let's try that again. Here I have 65. Here's the actual bearing I'm trying to find. Okay, so the boat is way down here somewhere. So this is the angle I want to find. I know part of it already. This little part right here is 25. I don't know this part. Okay, so I need to find that, and then I know this part right here is 65. So I need to figure out this little theta in order for me to know the bearing. And the way I'm going to go about doing this is actually to find what this entire measurement is inside the triangle itself, and then I'll just subtract the 25, and that will give me what theta is. So let's go back in and put in as many angle measurements as we can. So using alternate interior from this first place where we started to this next place, okay, I have this part right here is going to be 65, this is going to be 25. If I go 155, if I subtract 90 from that, this is going to be 65, and then this kind of extra distance here that connects the 155 to south, so 180 degrees total, is 25. And what do you know? We have another right triangle. And there's my key little bit of advice for you, is that every single one of these in this chapter is a right triangle, because this is called right triangle trigonometry. So every single one will end up being a right triangle. What I'll be looking for is the work that supports that that's really a right triangle. So I'll be looking for the work that shows me that you got 65 and 25 in there, and then it makes sense. So if this is a right triangle, we can figure out this distance by just using Pythagorean Theorem. So d squared is equal to 80 squared plus 160 squared. So d squared equals 32000. Square root of that. Generally fine if you leave it like that, or we can simplify. Again, I don't know what measurement knots is measuring in, so I can't really remember. So I'm just going to write units. You can use your calculator to approximate that. I just left it exact. So, all right. So now let's focus on finding the bearing. Remember that that's where this little extra drawing over here is coming into play. I'm going to label this entire angle, so it's measured by the big dark line, as this alpha. Okay, and if this is inside this triangle, here's my little alpha value. And I'm going to use tangent. Okay, so tangent of alpha is going to equal the opposite side, so that's 160, divided by the adjacent side, which is 80. Now, in order for me to get rid of this tangent here, because it's tangent of alpha, I need to use inverses, which we haven't officially learned yet, but you learned in geometry and probably did last year. So just gently remind you that that's what we do. We just type this in our calculator, okay? Making sure the calculator's in degrees. When I did this, I got that this alpha value is approximately 63.43. And if I jump back over here, alpha is equal to 25 plus theta. So I can just subtract 25 from this, okay, and get that theta is going to be 38.4349 degrees. And I know that my actual bearing is going to be 65 plus 25 plus that theta value that we just found. So the actual bearing that we're searching for, all of those added together, is 128 degrees. Okay, remember that it's different than what theta or alpha was because the bearing has to come from north, so it has to include all the angles outside of the triangle, which is basically at 65. Okay, and there you have it. That's the last one of the examples I'll do. We'll do the practice problems in class. All right. See you later, alligators.